Dark matter halos, the cosmic scaffolding that holds galaxies together. You can't see them, touch them, or detect them with even our most advanced telescopes.
Yet, they make up roughly 85% of the universe's mass.
Imagine an entire universe shaped by something completely invisible. This is the reality astrophysicists are dealing with today. But here's the twist: what if some of these dark matter halos never gave birth to stars?
What if entire galaxies exist
in darkness? In this video, we're diving deep into the latest discoveries about completely dark halos, massive invisible structures that could redefine how we understand galaxy formation and the very fabric of our universe.
So grab a drink, sit back, and get ready to have your mind blown by one of the universe's most profound mysteries.
First, let's understand what a dark matter halo is. Picture a vast, invisible cloud of dark matter. These halos act like cosmic glue, providing the gravitational framework around which visible galaxies form.
They are essential to galaxy formation.
Without them, galaxies would not be able to hold themselves together. Dark matter doesn't interact with light, meaning it neither emits, reflects, nor absorbs it.
That's why we call it dark.
Despite this, its gravitational effects are measurable.
We know it's there because we can see how it influences the movement of stars and galaxies.
Over the decades, scientists have confirmed that galaxies are embedded in these halos.
But here's where it gets strange: not all halos are the same.
Some are large and dense enough to form galaxies with billions of stars. Others?
Possibly, completely barren.
Traditionally, astronomers believed that dark matter halos needed to reach a certain mass, between 100 million and 1 billion solar masses, before they could begin forming stars.
The idea was simple: the more massive the halo, the more gas it could collect and cool, eventually leading to star formation.
This cooling, they thought, was primarily through atomic hydrogen, the most basic element in the universe. When this hydrogen gas cooled enough, gravity would take over, causing it to collapse into dense regions that spark star birth.
But a recent game-changer has shaken things up.
Enter Ethan Nadler, a computational astrophysicist from UC San Diego. His research introduced a more refined galaxy formation model by including the effects of molecular hydrogen, which is a more efficient coolant than atomic hydrogen. Nadler's simulations showed something revolutionary: star formation could occur in halos as small as 10 million solar masses, an order of magnitude lower than previously believed.
This new threshold flips the script.
It means that many smaller halos, once dismissed as too puny to form stars, may have actually birthed them in the early universe. On the flip side, halos below this new limit might have never formed stars at all, remaining dark and practically invisible. So what if some halos never formed stars?
We're talking about entire structures that may have existed since the beginning of time, but are completely invisible to us today.
This concept challenges everything we thought we knew about the universe. If these completely dark halos exist, they might vastly outnumber the visible galaxies. That would mean a huge part of the universe's structure is still hidden, a shadow realm within our cosmos.
But how can we detect something that emits no light? Astronomers have developed clever indirect methods.
One approach is gravitational lensing, where a dark halo's gravity bends the light from more distant objects, causing distortions that can be detected by telescopes. It's like seeing a ghost's shadow. Another method involves studying the motion of stars and gas in visible galaxies. If something unseen is exerting gravitational influence, astronomers can infer the presence of a dark matter halo. Understanding these hidden giants could also help solve one of astrophysics' biggest puzzles, the missing satellites problem. Simulations predict that galaxies like the Milky Way should have hundreds of satellite galaxies. But we've only observed a fraction of them. If many of these satellites are actually dark halos with no stars, the discrepancy between theory and observation starts to make sense. These dark halos aren't just side characters in the cosmic story. They're essential to understanding dark matter, the mysterious substance that makes up most of the matter in the universe. Different models of dark matter predict different behaviors for these halos. By studying their distribution, formation history, and gravitational effects, we can begin to test these models and inch closer to identifying what dark matter really is. For instance, Cold dark matter models predict lots of small halos, while warm or self-interacting dark matter models suggest fewer, larger ones. Observing whether the universe is filled with dark micro-halos or only a few massive ones could tell us which model is correct.
Let's rewind the clock to 1933. Swiss astronomer Fritz Zwicky was observing the Coma cluster, a collection of galaxies. What he noticed shocked him. The galaxies were moving way too fast to be held together by the visible matter alone.
Using the virial theorem, Zwicky calculated that the cluster must contain far more mass than what was observable. Kindly like, share and subscribe our channel for further more updates about space.